Hi guys, how's it going? This is going to be a quick lab. Should take us about 30 minutes. So we're going to explore network security groups and inspect the traffic between Azure Virtual Machines. I have a lab checklist over here, so you can follow the checklist. Um, yeah, so we can just get started. Basically, this is what we're going to be creating. Within the Azure cloud, we'll have a subscription. Then we'll create a resource group. I'm hoping you can see it. Yep, we'll create a resource group, and then we'll create two virtual machines. And within the virtual network, we'll have like two to submit or two machines, and it's basically to be able to communicate to each other. So yeah, we're just going to begin right away. Let's shrink this, and let's bring this down. Okay, so we have our Azure portal. So create a resource group. We will call it. First, we have to click on create. We'll call it RG networks. Make sure there's no space and create. Just refresh it. Hold on. Where is our resource group? Okay, it's here. All right. So we have our resource group. Let's create our virtual machines. Click on create. Oh, no, not that one. Go home. Choose virtual machine. Hold the phone. There should be a resource group here. Why is there no resource group? Okay, it's here. All right. We're going to create our virtual machine. And we'll put it into our resource group. We'll call this Windows VM. So we're going to have one Windows VM and one Linux VM. We'll keep the region as East US2. We'll leave the zone, we'll leave the machines. We will pick a Windows 10 Pro. Yep. And we'll have to pick a username and admin. We'll choose a password. We'll choose something very simple, lab user. And the password I'll just use is password123. Perfect. Then we'll confirm our licensing. All right, this time we'll not just click review and create. We would go to networking and we will create a new virtual network. So not the one that Azure creates for us. We'll call this lab2vnet in it. Yeah, I already wrote the names down so I could use them later. And we'll hit create. Okay. And then review and create. And then we'll create it. Now I have to wait a little bit for our resource to be deployed. And once it's done, we'll create the second one, which will be a Linux virtual machine. So if you hit refresh, you should see our resources being created. So you can see the virtual networks have been created, the security groups, the public addresses, the network interface. If we refresh more, you can see our virtual machine itself has been created. So let's just go to maybe resource groups. You can see a separate resource group was created. You can see the virtual machine, the virtual network, everything being created still. And it's been successfully deployed. I would say refresh it and actually just refresh your whole Azure portal before you create the second virtual machine. And we'll find out in a second why. So we'll just come here, click on create. Same resource group, and we'll call this Linux VM. Where is it? There it is. Okay, still East US2, availability zone, everything the same, and we'll use this. Okay, I guess it knew what I was going to choose anyway, so we'll just choose, Ubuntu 24. Do we want the 24? No, let's scale down. Let's go to a 22. Okay. All right, we'll choose password for this one so that we can use our lab user and password again. Again, something very simple so we can get this lab over with. There it is. Go to disks, networking, and you can see it's already put it into our lab 2 VNet. And so we just review and create, and then we will create. Now just hit create. Okay, while it's deploying, let's see what's next. What do we have to do next? Sorry. So next we're going to install, or we're going to connect to the virtual machine. We'll start with the Windows virtual machine. We'll install Wireshark. We'll open Wireshark and start packet capture. Then we'll filter for ICMP traffic and observe everything. Then we'll go to security groups. Okay, it's deployed, so let's just do it once and for all. So let's just go straight to, let's go to virtual machines. All right, this is our public IP address, so we'll be using this, or you could just come here. Actually, let's just do this first. Let's make sure that our both our devices are in the same virtual network that we specified. So if we check for Linux, you can also see that it's in the same virtual network. All right, they have their own public IP addresses and private IP addresses. Okay, so just come here and copy, and we will look for remote desktop connection. We will take it. Let's paste, call this lab user connect. And don't forget your password was password 123 dot. Yes. All right. Just give it a second. It's going to install. It's going to set up or log us into the virtual machine that we created. So give it a second. All right. Just say no to everything. Perfect. Say no. Okay. Dot data. Alright, so just look for wireshark.com, I guess. Okay, that's not. Let's just search for Wireshark. Okay, we'll hit install. We'll download. Okay, it's done. So let's click on open. And actually, what I want to do is copy this link. Let's do setup next. Noted. Next. Leave everything as it is. Yeah, we want to install that. Let's leave everything again as it is. Let it install. Agree and install. I need to stretch. Quickly. Almost done. Okay, finish. And we're done. So now let's fire Wireshark. Why is it not here? Normally it should be here. That's surprising. Okay. Alright, so open up Wireshark. So that's Wireshark. Alright, so you can see already it's picking up some traffic on our network. Right, so we just click on this and start capturing packets. So you can see immediately we are being flooded with so much traffic and so much data. So instruction says we should filter for ICMP traffic only. So let's go. CMP. You can see there's nothing on our network. So we have to go to our Ubuntu or our Linux virtual machine and attempt to, we have to retrieve the IP address, okay, and attempt to ping it. Okay, so let's see. This is where we are. Let's go to Linux. This is a public address, so this is a private one. So we'll just copy it, 10.0.0.5, and obviously we'll ping it. Okay, so let's look for PowerShell. Okay, and let's do ping 10.0.0.5, and immediately we can see the traffic going through, the requests going in and out of the hold the phone. Maybe I should increase it so you could see better. Let's do 18. Hope that works, or 20. Alright, 20 should do it. Okay, what's next? Retrieve the IP address and attempt to ping it from Windows. Okay, we did a pinging. Okay, then observe ping requests and replies within Wireshark, so we can see in here that everything, even though we had, it was just only 4 over here, this one is recording us saying hello to, or pinging the Linux server and them responding. So it's basically a hello, hi, hello, hi, hello, hi, basically kind of thing. Okay, and what's next? We should attempt to ping Google. Okay, so let's ping Google. Let's do ping google.com, and because we are connected to internet, our pings are going through and coming back, so you can see and observe the traffic happening on the ICMP traffic. And we're done with that one. Cool. The next is we're going to configure a firewall. So basically, first we have to do initiate a perpetual non-stop pinging from our Windows 10 virtual machine to our Ubuntu virtual machine. Open a network security group in your Ubuntu VM using hold on. Okay, so first we have to start our perpetual ping. Let's do this. We'll just have to add -t to it, and you see a non-stop pinging. It will just be this, and you can see it's also going down consistently over here. I say it's basically a hello hi, lots of hello highs. Even if you scroll down, it just keeps coming, it just keeps going, it just keeps going. Okay, so now what are we supposed to do next? We're supposed to go into our Azure portal, go back into the Windows 10 virtual machine, observe the ICMP traffic. Okay, we can see it. Oh no, we skipped the one. Okay, so let's go to the Linux and let's disable incoming ICMP traffic. All right, so we'll just go to Linux, and well, we're here, we're in Linux. We'll go to network settings. Yep, and in network settings we should find Linux security, network security groups staying there. And then when we go to settings, we'll find inbound security rules, and then we'll add a rule. So basically we are saying any traffic from anywhere that is coming anywhere near us, ICMP doesn't run on a port, so we'll just put a star there. We should deny it, and let's give this more priority than the next one, which is the 300. So let's give this 290 priority, and we'll add. So it's creating our rule, and the rule has been created. So let's go and see what happens to the traffic in here, because it was still sending, right? And very soon we should see a timeout request, or at least have complaints from. Okay, so you can see request reply, request reply, request reply. And now you can see no response, no response, no response, and you can see timed out, request timed out, request timed out. All right, so there we are. And it says now we need to re-enable the ICMP traffic for our network security group. So let's see. Okay, so just to do that, all we have to do is go back and delete our rule. So we would, hold on, give me a second. So we'll just go back, click on the rule we created, and then we would delete it and say yes. Perfect. Now let's see if it's picking it up. So it's supposed to pick it up soon and start pinging the requests again and allowing the traffic to come in, so you can just keep saying hello, hi, hello, hi. So you can see now it's back to the reply request, or reply from. Okay, so that's a good thing. And so we are done with this side, right? Back in this, blah, 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 blah. And then now we have to stop the pinging activity. So to stop the pinging, you just do Control C, and that should stop the pinging. All right, we're done. And now the next one is observe the SSH traffic. So we would click or search SSH here. Okay, and filter out the SSH traffic. Then from now, from the Windows SSH into your Ubuntu virtual network. So we're going to come in here and we're going to type, oops, battery low. Sound. All right. Sorry, I had to disconnect the microphone so that I could charge the laptop. So we're just going to continue now. So where were we? We were supposed to SSH. Okay, we're supposed to SSH ourselves into the Ubuntu's virtual network via its IP address. So this is what we're going to do. We're going to type SSH lab user. So let me see if I can shrink this a bit. Can I? Not too much, hopefully. All right, cool. All right, SSH, and we know the IP address already, 10.0.0.5. So we'll just do SSH lab user at 10.0.0.5. Okay, and you can see already we have SSH traffic running through, and we will say yes, and it will ask us for a password, and we'll type our password. And you can see that a password is not showing because SSH is encrypted, or everything in SSH is encrypted, right? So now we are logged into the Linux virtual machine via SSH. And now you can see when we type anything we type here, we're going to be seeing traffic because it's actively encrypting, right? It's actively encrypting. If you look over here, SSH protocol, where is it? SSH, right? It's on port 22. But there should be an encrypting something here. Normally you would see encryption. Am I in the wrong place? Okay, I can't find it. But basically, that's all you need to know, that as long as you are doing something in here, it's going to be encrypted consistently. Okay. All right. So what's next? So we're inside. Now I have to type a couple of commands into Linux so we can observe the SC traffic. So we'll just do one called, like, let's just call this, let's do ID, and then to tell us about ourselves, basically. And then we can do host name and tell us what our name is. So we're Linux VM. And then if you want to know more about the operating system, you could do uname minus A to give you more details about the operating system. What's next? I think we can even create a file. So let's just do pwd. Okay, and then we will do touch file.txt. And then we can do ls to see if the file is there, and it shows that the file is actually there. Now we will switch from this SSH to the SSH port, to TCP port 22, so that we can, and I'll show you why in a second. Let's exit this. Actually, let's do this. Let's go there so you can see what I'm talking about first. We can always come back. Filtering, so give it a second. Okay, so you can see there's the traffic that's coming in here, right? And the reason I wanted us to be here is so that when we exit, you would see the exits being executed, and you can see, right? We have already, that's our termination request, and now we are logged out. If we were in SSH, we won't have seen anything that would make us understand that it is logged out. This should take, see, I should have just done it before so we don't have to go back and forth anyway. Quickly. Yep, you can see nothing here shows you that this was the end, right? Okay. So we're done with SSH traffic. Come on. Yep. So you can see we're done with SSH traffic. All right. What's next? We're going to observe DHCP traffic. So we'll just type DHCP and enter. You see there's nothing in here now. And so what do we have to do? We're going to attempt to issue a new attempt to issue your VM, okay, a new IP address from the command line. All right, we're going to use ipconfig release. We're going to run that. All right. So let's do this. Let's see if we do ipconfig/renew. We can see a bit of traffic in here, Well, basically, we want to see more traffic in here. So what we're going to do is, if I just type ipconfig release as well, it will release our IP address and then to ask for a new one. It may not get a new one, it may get the same old one back, but it will log us out directly out of this virtual machine. So what we're going to do is rather we're going to go open Notepad. Yep. And we're going to type the IP. We're going to do ipconfig slash release, and then IP config slash renew. Okay, and we're going to save this. As an all files type, we're going to name it dhcp.bat. Yeah. And in this directory, we're going to do c program data. Okay, cool. All right, then we'll just save this here. Okay, and now we can run the command from here, and we will see when we run the command, we'll be logged out, and then it will automatically log us back in because it will release the IP. It won't have any IP address, and then it will get one, and then now we can log back in with the IP through the IP address. All right. So first, what we're going to do, we're going to do cd. I'm going to do c program data, right? Okay, and then we're going to do ls. That's going to show us a bunch of things over here. Okay, okay. We don't particularly understand. I don't particularly understand it myself. I just know I'm following the instructions I see over here. So the next one is to run the bat file. So we'll do dot, right? Where is it? Yeah. Dot slash dhcp dot bat. Now you can see the program was run. It's IP release, ipconfig slash release, and you will see what I was talking about in a second. So our remote desktop will disconnect only for a bit, and then it will reconnect on its own. So if I type ipconfig slash release, this is what is going to happen. Understandable. So I have to wait for a bit. It will, now that it doesn't have any IP address, it will basically ask, hey, can you give me an IP address? The server will send one, and then, again, it may not be a different IP, it will probably be the same IP address that has been given back, but at least we know this happened. And now you can see there's more traffic on here than there used to be, right? And you can see ipconfig release, this happened, and then ipconfig renew, and that happened. All right. And then let's see what's next. There's one more. Yeah, so let's say we wanted to see what was in there. We'll just do cut. Hold on. Dot slash dhcp dot bat. Right. And to just tell us what it did. Basically, it released the IP configuration, and then renewed it. So that's why we're able to log back in. So we're done with DHCP traffic. The next we're going to do is DNS traffic. So let's just filter for DNS. Okay, so now that we filtered for DNS, and there's nothing in here, what do we do? So we're going to use our command line, so basically PowerShell, and we're going to use, okay, yeah, okay, so you can see the DNS from the previous one. So what we're going to do is just wipe it, have a clean slate, okay, all right, no traffic incoming, no traffic there. And then we're going to do, what's happening? Oh, okay. Yeah, we, hold on. I'll close this and this, and then we're going to refresh. All right. Let's see if more will come. I'm sure something else will come because we have this connected. Yes, because our Google doc is opened. But let's just let's see. So the more I interact with it, the more stuff will happen, I guess. All right. Let's do. What did they say we should do? DNS. Okay, DNS. Use NSLookup to see what Google's and Disney's IP addresses are. So I'm going to do this again. Oh, don't save, cancel. Oh no. All right. So we're going to do NSLookup google.com. And already you can see more DNS traffic poured in, and we're going to do another for disney.com. Oh, I should have done NSLookup first. Yeah, disney.com. And there's even more traffic. All right, and you can see Google servers. So if we did this, we took one of Google's servers. Wait, is this Google server? Yeah, this is Google servers. Yeah. And we went and pasted it here. We may not get anything proper, will we? Okay, yeah, we did. So now let's try the same for Disney. So normally people don't, I mean, you normally won't get any proper response if you do this. But for instance, if we do Disney, we're in for a, oops, sorry. I'm just pressing Control V and I keep messing up. Oops. For Disney service, we'll say advanced, say continue. And what will we see? A cartoon waiting for us with an arrow for. Alright, so we're done with DNS traffic. We've observed it, we've seen what comes out of it. What is next? RDP. So for RDP, it's pretty simple. So let's say, let's continue without saving. Let's just type RDP. We may not see anything happening here, but RDP runs on TCP port 3389. So what we're going to do is find that port, and you can see a constant stream of data, immediate non-stop spam of traffic. So what do you think is causing the spam? It's because RDP is constantly showing us a live stream from one computer to another, and therefore the traffic is always being transmitted. All right, so now that we're done, you can close out your labs. You have to close your remote desktop, but let's just see. You can just close everything, continue without saving, or you could just, leave it. All right, now let's just close everything. And then come to resource groups, because everything you can see has ended. Okay, and just close this. Just come to resource groups, then go to RG network activities, delete resource group, delete this as well, apply, and delete again. Now let's delete this as well. Okay, so we just wait while the resources are being deleted, and then we would check to make sure that our resources have actually been deleted. So if we check the lab checklist, we come all the way down here, close your remote desktop session, delete the resource groups, and verify that the verify resource group deletion. Okay, so we're going to wait, and you can see the navigation bar at the top is sliding. You could just click on the notifications and wait for good news, or just sit here and just restore it. Let's just wait. You can see Network Watcher RG has been deleted first because there was not a lot of resources in there anyway, and so it's gone. The next one is RG Network Activities. And it's gone. So we can come to Azure. Let's come home. You can see all these things. Just do, and you can see both of them have been deleted in all resource groups. Just do a quick refresh over here to make sure that nothing is here apart from your subscription, and that means that you've actually cleared everything. So that brings us to the end of our labs. Hold on. Yep. And so we're able to explore network security groups and inspect the traffic between Azure Virtual Machines. Have a good one.